So today's lesson we're looking at power, and that is your title today. So you want to write down your title, power, the date today, and can you write down your keywords, powerful, watts, and rate of. So you should be able to pause the video now while you write that down and then move on. Okay, so looking at what power is. So power measures how much energy you're able to transfer per second. So I've got two cars here. I've got two questions I'm going to ask you to think about, discuss, and then feed back to your teacher. Okay, and then I'll go through the answers after you've done that. So, which of these cars is more powerful? It's got a Ferrari and a smart car. They're both petrol-powered cars. Both work the same way, but they're very different. So, which of these is more powerful? Which is the more powerful car? Okay, think about that. So, thinking about what power means, think about which is more powerful. And which will use its petrol faster, so which is going to use up its store of chemical energy faster. So if you filled them both up with, say, 10 litres of petrol and drove them flat out as fast as you could, which one's going to use up that petrol faster? Okay, so think about it, discuss it, and then obviously pause the video while you're doing that, and then I'll come back with an answer. So the more powerful one is going to be the Ferrari. That's because it transfers more energy per second, so it's going to be able to get up to speed faster. It's going to accelerate faster, get its kinetic energy faster. It's going to just be a faster car, and therefore it is going to use its petrol faster as well. Okay, if you drove both of these, you would be filling the Ferrari up a lot more often than you'd be filling the smart car up. Okay, because it's got a more powerful engine, because it's transferring more energy per second, it's going to use its energy much quicker than the smart car is, and you're going to run out of petrol, run out of chemical energy much faster. Okay, so let's think about how we would measure something's power. Okay, so if I was to test how powerful I was, and I've got a set of weights, what sort of things do you think I would need to know? So what things would I need to measure? So just 30 seconds to discuss again. What things would I need to know to test how powerful I am? Okay, so we'll come back with an answer. Now, I would need to measure a few different things. The first thing I need to know is how much weight am I lifting and how much force does it take to lift it? Okay, so if I was lifting this weight or if I made it a bigger weight, okay, it's going to affect how much force I need to lift it, and that's going to affect how that'd be, if I measured how much I could lift, that'd tell me how powerful I am. Also, I need to know the distance I'm lifting it. Okay, now if you remember, these two things go together to make work done because we've done this before. So work done equals force times distance. So if I know the force and the distance, I can look at how much work I've done or how much energy I'm using. Now, because though power we've said is how much energy we're able to transfer per second, I'd need to work out how much energy I'm using these two things, and then I'd need to know how many seconds it took me to do that. So I'd also need to know the time to lift. So how many seconds did it take me to lift it? And the quicker I can lift it, the faster I would be. Okay, so things like you could say, if you were, for example, saying like who's a more powerful athlete, okay, or who's a more powerful runner out of a 100-meter race, it'd be the person who finishes fastest because they're doing the same distance, okay, the same sort of force, they're just running, okay, so it's the same sort of force, but if they're doing it quicker, they're going to be more powerful. So the quicker you do something, the more powerful you are going to be, okay. So power is how much energy you're able to transfer per second. It's how fast you're able to transfer your energy. And it depends on three things: the force that you're able to produce, the distance that you're able to move something, and the time it takes you to do that. So the force and the distance make your work done, and the time it takes to do that decides how powerful you are. Okay, so I'm going to give you a chance now to write down what you think power is. So I want you to write in your books I think power is, and write yourself a definition. And then I want you to put power depends on, and then can you think of 3 things that could affect how powerful something is? 3 things we just talked about that affect the power of something. Okay, so give you 2 minutes to write your definition down. If your teacher can just pause the video now. Okay, so hopefully you've had 2 minutes to write that down, and I'm going to show you the answer that I would put now. So I would say, and this, you can write this down as your class definition, please, or your proper definition. Okay, so again, once I've shown it, you just pause the video so you can write down the proper definition. Okay, I would say power is how much work is done each second. Okay, now another way we can think of that is the rate of, sorry, just all, I'll place my zoom there. The rate of energy transfer. So that's another way of defining it. That's somewhere you might see it sometimes, but it's how much work is done or how much energy is transferred per second. Now, rate of energy transfer just means the same thing. So rate of means per second. Okay, so energy transferred per second. Right, it's measured in watts. This bit you might want to add that you probably haven't got because I've not really told you that yet. But it's measured in watts, so that's the unit for power. We'll come on to the units in a bit because there is another unit for it. And it depends on 3 things. The force that you need to do something, so it might be lifting something, it could be pushing something, whatever it is. The distance you move it, and the time it takes you to move it. So those 3 things are what power depends on. Okay. So because this is a physics lesson, this obviously works out into a nice little equation. Okay, and it is this up here. So I'll go through this step by step. So I'll just cover it back up again. So we've got energy or work equals power times time. So energy and work are the same thing. Okay, we talked about this before. We did a work done lesson. We said that energy and work are exactly the same thing. So work done is the amount of energy you transfer, and it equals the power times the time. So how much power you've got times time. So units for these things. So we know what the units for energy are. Oh, sorry, symbols first. So symbols for energy is E, symbols for work is W, symbols for power is P, symbols for time is T. Make sure you're getting your cases right on this. So energy and work are capitals, power is capital, but time is a lowercase t. So they're your symbols. So if you wanted to write E equals P times T, if you wanted to write it a bit shorter, you can do that. So if you don't want to write every time energy equals power times time, you write E equals P times T. Right, units then. So energy we know is measured in joules, okay, or capital J. That's fine, that's easy. We've done that one before. Now, time also we know is measured in seconds. Now there's 2 units for power, either joules per second or watts. So you can either write at the end, if you're working out power, when you worked out the answer, you can either write your power in joules per second or watts. Now sometimes they will ask you questions like, it'll say a car transfers 800 joules per second, what is its power in watts? And it'll just be 800 watts because they're the same thing. So 1 watt is 1 joule per second. And time obviously in seconds there, we've done that one. So this all needs to be written in your books, please. Okay, so pause it again, write everything on here in your books, and we will move on. Okay, so let's have a go at a question. We'll not do this in your whiteboards. And we'll go through this with you, okay? And I want you to write it in your book. So we've got a microwave, and it's got a power of 800 watts, and it cooks a meal in 45 seconds. And want to know how much energy is that transferring in that time, okay? So what's our first step going to be? It should be to highlight anything we've got in the question and see if there's anything needs changing or anything like that. So we've got a power of 800 watts, cooks a meal in a time of 45 seconds. How much energy has it transferred? Okay, so that's what you should be highlighting. In fact, it might be a good idea just for this one. I know we don't normally do this because I'm not there with you. Can you write the question down and just either underline or circle or highlight if you've got one of the things that I've highlighted? So I'm going to pause this now while you just write that down, and then we'll go through how we're going to answer it. Okay, so once we've written that down and we've highlighted the things we've got, we think, right, are these in the right units? So let's go back to our equation. So energy we don't know yet, so we'll not worry about that one. Power should be in watts or joules per second. So is power in watts or joules per second? Yep, it's in watts. It's not in kilowatts or megawatts or anything like that. It's in watts already. Right, time should be measured in seconds. Okay, we've written that down. So it is measured in seconds. It's not measured in minutes or hours. It's measured in seconds. That's good. So we now, next step is our formula. Okay, so I'm going to put F. I'm going to put these letters down the side to remind you what we need to put. And I want you to be writing this out with me, okay? So whatever I write down, I want to see you writing the same thing. So F formula is energy equals power times time. I could put W for work equals power times time. It would be exactly the same thing. It wouldn't matter. But because it says energy there, I'm just going to write E for energy. Now I put my numbers in next. So do I know my energy? No, I don't. So it's just energy equals. Now I do know my power is 800 watts times my time of 45 seconds. This is a nice easy one because this is given it in a way that I can work out straight away. So just type in my calculator, 800 times 45. Give you a second to do that yourselves if you've got your calculators. Okay, and we should have got an energy of 36,000. Okay, and then the units for energy are going to be joules. So don't get confused just because we were looking at power today. Not every unit is power. This time we're working out energy, so that'll be joules. Okay, so check what the answer should have been. 36,000 joules. We've got the right answer. But that's what this should look like. So you should have this written down in your books now, exactly like this. If you haven't, then give yourself a second to do that. Pause the video again to do that. And write all those things in. Okay, let's move on then. So if we've got one like this, I'll get rid of the extension for now. I don't think we need it for now. We've got a hairdryer which is running for 3 minutes, does 108,000 joules of work. What is the power of the hairdryer? So this time, again, we're going to highlight our numbers, things in the question. So I've got 3 minutes, 108,000 joules of work, and I want to know what is the power. Okay. So this time though, thinking back again, right, is my energy in, what do I want my energy in? Joules. It is. Is my time in seconds? Okay, it's not, is it? It's in minutes. So what do I need to do to get my minutes into seconds? Okay, I need to convert it like this. I need to do 3 minutes times 60 seconds is 180 seconds. Okay, so don't need to particularly write the question out this time, but can you write the answer out again with me this time for this one? So my formula, same as last time, energy equals power times time. Now, just because I'm working out energy this time, doesn't mean I change my formula. My formula is always the same. I'm not working out energy this time. I've already got it, but it doesn't matter. Okay, now I'll put my numbers in. Now, this is why it's important that I've already converted my numbers into the right units. So I've already got my minutes into seconds. I've got my joules as they should be in joules. So I don't need to do anything now. I can just stick my numbers straight in there. So it's going to be energy. I'm going to follow across my equation. So first off, do I know my energy? Yes. It's 108,000 equals, I don't know my power, so I'm just going to put a P times my time, which is 180 seconds. So what do I do with this now? Okay, I've got 108,000 equals P times 180. So 180 P's is 108,000. So I want to work out what 1p is. So what I do is 108,000 divided by 180. Let's put a little line in there. And that will tell me what my power is. So that equals power. Right. So if you do that on your calculators now, and I'll do it on mine. That'll give us an answer of 600. And my units are going to be a capital W for watts. If I put joules per second, that would be equally correct because there's 2 units of power. I can choose whichever one I want to use, but I'm just going to use watts for today. So 600 watts is your answer for that one. Okay then, so now I'm going to let you have a go at some questions in your book. So I want you to try and do all of these if you can. And you've got to be aware of a few things. So first off, do check that you've got things like we've got kilojoules here. So kilo means 1,000. So 20 kilojoules is going to be 20,000 joules. Okay. If you've got minutes, okay, some of these questions down here, where have they gone? Yeah, 3 minutes. Okay, that's going to be 3 times 60 seconds. Okay, so work your way through these. Some of these first ones you've got to do like you've just done on this one, where you put your numbers in and then you have to rearrange it, make it into a divide to work it out. So pause the video now again, obviously. If your teacher wants to open this up on the slides, if that looks better than it opening up on the video, leaving it on the video, that's fine. Or leave it open on the video. And just take your time. There's 9 questions to go for. That should take you at least 10-15 minutes. Okay. I want every question full working out. Formula, numbers, answers, units. If I come back and I see I've got all these in your books, I'll be very pleased. If I see you've just written loads of answers with no units and no working out, I'm not going to be very happy. I'm not just making you do that again. Okay. So make sure you've got full formula, numbers, answers, units. Okay. So pause it now and we'll come back in a minute. Okay, so once you've done that, you've got a sheet to do, okay, and I want you to try and fill that in. So once you've worked through all these, you should also have a little question sheet to do. So I will go through the answers to these ones first, and then if your teacher can hand out those little sheets to you, and that should be your last task for today, and hopefully that will finish off what you've got to do today. But I'm going to show you a little extension as well. So what is a power of a fire engine in 1,000 joules in 200 seconds? So I'll go through what we should have done. We should have ended up, this should be 1,000 equals 200 times power. So it should be 1,000 divided by 200, which will give us 5 watts. So 5W, 5 watts. Power of a crane that's 20 kilojoules in 30 seconds. So 20 kilojoules is 20,000. It's going to be 20,000 divided by 30, which will give us 66.7 or 66.666666. So I'm going to round it to 66.7 watts again. Next one, the power of a kettle, so it's 1.2 kilojoules times by 1,000 is 1,200, 1,200 in 3 minutes, and 3 minutes is 180 seconds. So 1,200, 1,200 divided by 180, it gives us 6.7 or 6.66666 watts. Right, next one. This time we wanted to find the time. So to find the time, we end up doing our energy divided by our power. And don't be careful with this because it would be 850 equals 2,400 times time, right? And that rearranges not to 2,400 divided by 850, but 850 divided by 2,400. So be careful with those. The ones like this, where the bigger number isn't big number divided by small number, often catches people out. So you should have done 850 by the end time you rearrange this, 850 divided by 2,400, which gives you an answer of 0.35. Okay, so it's 0.35 seconds. Okay, right, next one. So 7.5 kilowatts, that is 7,500 watts and 125,000 joules. So you should do 125,000 divided by 7,500. To give you an answer of 16.7 or 16.66666. Obviously I'm rounding again, and that's watts because it's power this time. Next one, 3.4 kilojoules in kilowatts. So I'm going to do 3,400 divided by 1,200, and that'll give me 2.83 seconds. Moving on to the next one. So 2,300 watts and 240 seconds. So that is power times time. So it's 2,300 times 240 is 552,000. And this time that is going to be joules because that's working out the energy. Next one. So 4.6 kilowatts. That's 4,600 times 3,600 seconds. So 4,600 times 3,600 and that gives you an answer of, I'll write this down, I'll not say it because it's a big number, but it's 1656, and then you want 1, 2, 3, 4 zeros. Okay, so big number, and that is joules. Your energy is often going to be quite big, especially when it's like a dryer. That's going to be on for a long time, so it's going to be a big number. So if we want to say that though, that is 16,568,000 joules. Right, last one then. So how much energy is Chris Hoy transferring? So 3 minutes is 180 seconds times 490 watts. So 490 times 180 is 882,000 joules. So 8820. 88200. Oh, sorry, 88,200 joules. So 88200 joules. Right, so a couple of things to do to finish off the lesson today. Hopefully we've got most of those right. They've got some questions on your sheet, and if you've done that, what I want you to do is try and think about the adverts. This is an extension, so you want to work through the sheet, and then this is your extension to finish off your lesson. So what are the advantages and disadvantages of having a powerful engine in your car? Okay, so a car with a powerful engine, there's lots of good things about that, and there's lots of bad things. I want you to make a little table of it, and then write me a paragraph. So you want to make a little table first in your book saying advantages and disadvantages, and then you start with like one advantage of having a powerful car is, and you put, and then you'd fill that in, and you say, however, one disadvantage is. So think of what's good about having a powerful car and what's bad about having a powerful car. We talked about this with the Ferrari and things, but think about what we talked. Advantages are probably quite easy, thinking about how fast it is and stuff. But disadvantages, you might have to think about like which one, how much is it going to cost to run if it's more powerful? Okay, if you've got a big powerful engine, what's that going to cost you in the petrol that you're buying and stuff like that? Okay, so you want to start. So do a little table to give you some ideas, and then one advantage of having a powerful car is, and answer. However, one disadvantage is, then answer that as well. Okay, so if you pause the video now, leave this up on the screen. Okay, and so you want to work through the worksheet that you've got, and then this is your extension question up on here. So you make a table and then do this. And I'm hoping that most of you will have got to this stage by the time I get your books back. All right, have a good rest of your day, and hopefully I'll be back in to see you soon.